Welcome to the first lesson in Algebra 2. We're going to start with a review in real numbers and number operations. Now, this is material you probably learned back in Algebra 1 and probably as far back as pre-algebra. What we intend to do in this lesson is to kind of formalize some of the things that you probably learned as properties and various things of that nature. We'll start with a basic understanding of real numbers and sets and subsets. Now, this first video and these first couple of lessons, you're going to notice as there's not as much problem solving and work to do, but a lot more understanding of terminology and symbols and things of that nature. Please do not discount the importance of these lessons, as they may seem somewhat uninteresting and unimportant to you going forward. You will need to know this information very well as you move into advanced math and calculus or college algebra and trig, and as well as the ACT. All of this information is very important, so please take the time to study this information closely. Okay, so we're going to start off with some basic terminology and some basic understandings of real numbers. And so we're just going to follow the note-taking guide here. It's important that as you go through these videos with the notes that you take notes yourself. Not everything is encompassed here in total, so I will say things that are not part of the notes. I'll make little notes out to the side, and it's important that you do the same. And if I mention something that you're unclear of, it's very important that you also take notes and write down questions to ask your teacher in class at a later time. So very important that you do that so that we can fill in any missing holes that we did not touch base on here. So we'll start with a basic understanding of sets and what numbers, real numbers are. And so we can see here that anytime we have a grouping of numbers in a specific purpose, we call that a set of numbers. And we'll use these little braces to define the set or to identify the set. And of course, just like in geometry, how you use symbols to represent things, we can use capital letters to name a set. So you can see we have set A and we also have set B. Now, if you look closely enough, all of the letters, or excuse me, all of the numbers in set B are also part of set A. And so this is where we get into the term subset. Okay, and so B is then a subset of part A, and you can see the symbols that we use to write language in mathematical terms. So a lot of that is going to be learning how we take the English language and create a mathematical set of properties or symbols. Okay, so we're going to be discussing what's called the real number set. And the real number set has a number of subsets associated with it that you must learn, and this is very important. So we're going to go through each one of these quickly. You should be able to read these and kind of put some understanding to it. So I'm just going to hit some of the high points for each of these subsets. And so we start off with the natural numbers. Now, natural numbers are a lot of times called counting numbers, because if you look at the set of natural numbers, they start with 1, 2, 3, 4, and of course that's how you learned how to count when you were probably just a young person of 2 or 3 years old. So you started with 1, 2, 3, 4, and we called those counting numbers. Well, in the real number set, they're called natural numbers. Now, each of these subsets is going to have a symbol, if you will, to represent them. It's important that you learn those symbols and you recognize those symbols when used. So, our most basic subset in the real numbers are natural numbers. Now, these numbers go on infinitely in a positive direction, and we can show that through the little 3 dots that show a continuation in a particular direction. So it's very important that you understand that these will go on infinitely in the positive direction. Now, we move on to the whole numbers, and the whole numbers are all of the natural numbers, just simply with the number 0 put at the front of that. So we will move into whole numbers. Now, whole numbers is one subset of real numbers that we use quite frequently. and is used in the directions of many standardized tests. So it's important that you understand that as well. As we move forward, we're going to then add or include the negative values of all of the natural numbers, and this is what we would call the integers. And so integers is a very popular set of numbers that we use for lots of operations in mathematics and specifically in algebra. So you must know integers very well. And you can see on the integers we have the 3 dots at the front of the set of numbers, which means that it also goes infinitely in the negative direction as well. So very important you understand that. Now, those 3 sets of numbers are common sets that you learn in pre-algebra and algebra 1. As we move into algebra 2, we're going to start focusing on 2 other sets of numbers that are a little bit more involved, and that's the rational numbers and irrational numbers. Now, the rational numbers are all of the numbers from counting numbers, whole numbers, integers, but then we go into a little bit more specifics. If you look at the rational numbers, it says that it can be expressed as a quotient of 2 integers. This is really just a fancy term saying that it can be written as a fraction. Okay, so quotient, remember, is division, and so basically if you take 2 integers and you write them in a fraction notation, then it can be represented as a rational number. Now, let's clarify a couple things about rational numbers that's going to help you separate it from irrational numbers. The set of rational numbers is going to include all repeating and terminating decimals. So if we look at a couple examples of that, let's think of it this way. If we have 3 divided by 4, which is a fraction of integers, if we put that in our calculator, that becomes 0.75 and then it stops. It no longer goes any farther. So it is what we call a terminating decimal. So that's a rational number. If we look at another fraction of integers, such as 1/3, and we put that into our calculator, we're going to get something that's got 0.3333, and it goes on forever. And if you recall from grade school, you would put a little repeating bar above that. Well, that would be considered a repeating decimal. So that is also a rational number. Now, that is a very important concept for you to understand, because as we move down here into irrational numbers, we are then dealing with numbers that cannot be expressed as a quotient of 2 integers, which means that they cannot have decimals that are terminating and they cannot have decimals that are repeating. So if we look at an example of that, we could say the number, our symbol pi, which is 3.14, and then on and on and on, never terminates and it never repeats. So it is considered an irrational number. Okay. Now, if you notice in the definition or the description of rational numbers and irrational numbers, we have a couple of different symbols in there in the set, and we call this set builder notation. Now we're just going to introduce this concept to you in Algebra 2. They'll probably go into more detail about set builder notation in advanced math, but let's just look at how this reads. If you look at the set builder notation for a rational number, it has p over q, which are representing integers, and that little bar represents the word such that. And so this reads the set of all elements p over q such that p and q are integers, but q is never equal to 0. And the reason it's not equal to 0 is because it would make it an undefined number. Now, if we look at irrational numbers, our set builder notation is basically telling us that irrational numbers are all numbers that are not rational. So anything that's not rational is considered irrational. So this set builder notation reads the set of all elements x such that x is not a rational number. So very simply, irrational numbers can be identified by any number that is not a rational number. So these are going to be very important in your Algebra 2 education. Very important that you understand and know how to identify those number sets. Now, let's look at what that looks like visually. And so you can see rational numbers are a completely different set of irrational numbers They both lead to real numbers, and of course each subset here, the natural numbers lead to whole numbers lead to integers, and integers lead to rational numbers. So none of these subsets are part of irrational numbers. So that concludes the start of our first lesson. I'm going to stop right here so that you can kind of digest some of that information. There will be a couple more videos that go with this first set of notes, so be sure to watch those as well before you do your first set of homework.